Welcome to a series of database management system video lectures. Today we'll be discussing about Unit 2, Topic 7, that is normalization. Now, what do we mean by a normalization? What do we mean by a normalization? So this is a series of steps which converts any data which has any data that can be converted become to avoid the anomalies. What is normalization? Normalization is a process of removing redundancy of data and removing all the anomalies. So both these important points that can be covered with the help of this normalization. Actually, we should know that what is the necessity to perform normalization process. Before we get into this, in the previous video, we have discussed about what do we mean by an anomaly, how these anomalies are occur in the database, and what are the types or the categories of the anomalies that we encounter while dealing with any data. So when we deal with any database, we may come across with the various types of anomalies, and with respect to these anomalies, there is a possibility of linking multiple number of tables, which again leads to a redundancy of data, and then depending on one element of one table to the dependency of another attribute of the another table. So this sort of thing happens when we try to perform any kind of insertion or deletion or updation operation upon the database. There is a possibility of not performing as designed. So all these were the technical problems that have been encountered, and let us resolve this by doing a normalization process. So this normalization is a process which contains or which has taken place in various phases, which can be named as first normal form, second normal form, third normal form, fourth normal form, third normal form, BCNF, voice code normal form, fourth normal form, and then fifth normal, then fifth normal. So the main intention of designing this normalization process is to Design a database schema that minimizes redundancy and it ensures data integrity by reducing or eliminating all the likelihood of the data. Now let us consider this library database. With respect to this database, we will walk through with the normalization process. This library database contains various attributes, book ID, title, author, journal, publisher, and year published. We have four records of information. Let us look at this data and how this is being normalized. Okay. So now we have the first normal. Now this first normal form states that it should ensure that each attribute should contain only atomic values. So atomic values are up here. That means a single valued functional dependency is going to be implemented by the first normal form. So here it not only allows atomic values and it also eliminates repeating groups by putting each group of related attributes into a separate table. So let us not create any kind of groups of repeated set of attributes from one entity to the other entity. Now look at this. Now for book ID column, we have single atomic values only. Look at the second column, that is title. So the title is also taken as the single value only. Now at the author, for the author column, we have a combination of different author names, right? So now I wanted to, if more than one author value is being provided, then we need to break down this particular table into multiple number of smaller subtables, or you can decompose it into smaller subtables. Okay. So it will not allow to take this. So instead, create another table with the name author database, author table, wherein you can give an option for the author name to be first name, middle name, and then last name. These composite attributes can be defined for the author name. Then the next one is second normal form. Now, what is second normal form? Now, to bring the data into second normal form, make sure that the data is already in first normal form. So, second normal form always builds upon first normal form by ensuring that non-key attributes are fully functionally dependent on the entire primary key. Now, here, what are fully functional dependent? Now, if we say that if we say that X is dependent on Y. We say that X is dependent on Y and X has got a set of attributes as A, B, C. And Y has the attribute set as D, E, F. If X determines the value of Y and if any removal or updation of an attribute from X will lose this functional dependency. So this is what called as fully functionally dependent. That is second normal form. So which will eliminate all the partial dependencies where non-key attribute depends only on part of the primary. Now the next one is third normal form. This third normal form can be done only when we have the data which is already in second norm. So that's why It builds upon second normal form by ensuring that non-key attributes are transitively dependent on only on the primary key. So now, what do we mean by transitive dependence, which we have already discussed here? When X is a group of attributes and Y is other set of attributes. When X determines Y and when Y determines Z, so logically, we can conclude that X determines Z here, right? So this is a transitive property that holds here. Huh? The next normal form is voice code normal form. It ensures that the data is already in third normal form and we wanted to apply a certain level of a strict rules upon this data. So a strict form of third normal form where every determinant is a candidate key. Now here is a new type of key that we have come across with. So candidate key, super key, foreign key, these are going to be discussed as part of unit 4 in later videos. But for the time being, let us understand that what do we mean by candidate key. So candidate key can be given to any non-key attribute to identify the record in a unique manner. In a unique manner. Now, this voice normal form, it eliminates non-trivial functional dependencies where non-prime attribute determines another non-prime attribute. Now, the next one is fourth normal form. Fourth normal form obeys the concept of multi-valued functional dependency. Okay, so which indicates that there mustn't should be multiple values that are being provided to the attributes. So in the previous scenario, for an employee database, we have contact number as the multi-valued attribute, right? So we should even consider multi-valued attributes to be decomposed into other smaller subtables in order to take 100% of data from the use. And finally, we have fifth normal form wherein it implements the joint dependencies. So, and it addresses joint dependencies where a table is affected by combination of keys and the other tables. So when we have a dependency relationship from one table to the other table, let us try to decompose into smaller subtables so that we can have atomic values and then there will not be any dependencies that are being done. So this is the fifth normal. Now look at the example that we have taken, the library database. So here only the author can be taken with the composite attributes. Okay. So now, after converting this into first normal form and second normal form, look at here. Author is taken out from the books table, wherein author can be exclusively identified with the author ID number, first name, and then middle name or last name can be taken as a separate table. And then next is book authors table, that is nothing but a relationship wherein it represents the content of both the contents of both the associated entities. So after undergoing into various phases or series of normalization process, this single table, this single library database is being decomposed into three different tables. That is a books table, author table, and an author book table. So author book table here is a relationship. So it is trying to relate or establish a link from books table to the author table through the verb as book authors table. So both the tables have got all minimum information as part of it. So now this will be the end of normalization process. Thank you.